Hi, welcome to another lesson with Dr. Hill. Today we are talking about genetics. And in our previous lesson, if you haven't watched it, you should go back and watch that. We crossed a homozygous dominant stripy rodent with a heterozygous stripy rodent, and we got 100% stripy rodents. Now, we suspect that our recessive gene for spottiness in there, it's the little h, remember, we called it, is in that population, but we have to try and figure out how to produce some individuals who are going to give us spotty offspring. Perhaps we want that for some reason. Perhaps we run a pet shop and people like spotty rodents. Who knows? Hopefully it's a humane pet shop anyway. So let's have a look at the board and we'll see roughly where we're up to. Now in our last lesson, if you remember, what we did the parental cross with this. We called it H rather than coat pattern C or P or S, because none of those letters is useful to us because the big letter looks the same as the small letter. Here a big H is clearly different from a little h, so we used that. We did the cross big H with big H little h, homozygous dominant and heterozygous, and we got 50% homozygous dominant and 50% heterozygous offspring. So they're all still stripy. So I've crossed these two and all my offspring are stripy. What can I do? How can I get some spotty rodents? So let's see. I've laid it out here, the problem. And this is our parental generation, our parental cross, remember? These are the two individuals we started with. Now what we're trying to do is we're trying to breed some spotty rodents. Spotty rodents. Okay, so this was our first cross. The F1 generation gave us 50% big H and 50% big H little h. Now, it might be 50%. This is our probability. Genetics is random, and it's very important to remember that. The outcome of the cross is never necessarily going to be exactly 50-50. It might be 60-40, or it might be 35, whatever that is, 65. So what we have to remember is that we're going to get some offspring. All of these offspring, they are all stripy. They all look stripy. So I have to just randomly select males and females from this generation, the F1 generation, and I do an F1 self-cross. So this is the offspring of a cross crossed with another offspring of the same cross. So this is an F1 self-cross. So this is the filial generation. Filial, F1 we call it. F-I-L-I-A-L. It means brothers, essentially, brothership, which is rather odd because there's males and females in here, but never mind. So if I take these and cross them, there are three possible crosses that can happen. Now I can't pick these individual genotypes out, so I just have to randomly cross the individuals and see what comes out. So let's have a look. In this case, all the offspring, I can tell just by looking at this, all the offspring are going to be 100% big H, and they're all going to be stripy. So that's no good. This is my F2 generation. The next generation down, F2. So if I cross those, that's going to be what I get here. This is slightly more complicated, but that's the same as the parental cross we just did. Nick, see that cross there is the same as this cross up here, so you know what the outcome is. That's going to give us 50% big H, and 50% big H, little h. So our only hope really for finding some spotty offspring, remember spotties are going to be homozygous recessive, is this cross. So let's focus in on this cross over here and we'll do ourselves a Punnett square. I'm going to do a slightly smaller one just over here so that we can look at the results. It's really just noughts and crosses, so there's not much point. So I've got a big H, little h, and a big H, little h. That's going to give me big H. That's going to give me big H, little h. That's going to give me big H, little h. And the H, that looks like an L, doesn't it? And this one here is going to give me little h, little h. Okay, so there's a possibility that 25% of my offspring are going to be spotty. Okay? So what I will get if I do this is I will get 50% 50% big H, little h, 50% heterozygous, 25% homozygous dominant, and all these guys are going to be stripy, right? But there's a chance I'm going to get 25% little h, okay? So this is my F2 offspring. Now these are all stripy, all over here, all stripy, no good, stripy or cheap, all stripy. This isn't telling me anything because I can't see the difference. Yeah, you can't really look at these genes unless you're able to actually do the genetics work, the molecular biology. But what we've got over here is I've got 25% of them are spotty. And now I can easily pick a spotty one because the phenotype or the genotype is going to be little h. So I can do my F2 cross is going to be little h. Hopefully I've got a male and a female of each of those, and that will give me all spotty. And then I can keep breeding from those individuals. All of these individuals can breed with each other, and I will always only get spotty rodents. So my pet shop can make a bit more money. My humane pet shop, I should add. Okay, so I hope that made sense to you. If it didn't make sense, there's a lot of information in there, so go back and watch the video again. We'll just summarize. In order to get to our recessive phenotype, we have to do a series of crosses. We have to cross the parents. The parents were both stripy, and then all the offspring were stripy. But taking different members of that offspring from the F1 generation, we're going to stumble across a combination of individuals, hopefully, that will give us some spotty offspring. And we've laid it all out there on the page. And if I crossbreed those spotty offspring in the F2 generation, that'd be an F2 cross, then I will have a true breeding line of homozygous recessive spotty rodents. All right? Any questions, put them in the comments below or see me when you see me at school. And otherwise, I'll see you in the next lesson.